Hi guys, Mrs. Sugi here, and this video is going to cover inverse trig at the Algebra 2 level. So this warm-up is just like basically what we did in algebra or in geometry. So when we are going to be doing inverse trig, that means we are going to find the measure of the angle. So let's kind of review what we went through in geometry. I'm going to go ahead and label that as theta instead of the question mark. So inverse trig all starts with SOHCAHTOA. So this, from this angle, this is opposite and adjacent, so that is a tangent. So the difference is, right, we have a theta instead of a number to put in there, 27 over 38. All right, and then what we did back in geometry is we just did 27, I got a weird glare, 27 divided by 38. And anytime that you are dividing two sides on a triangle, you basically are generating one of the numbers on this trig ratio chart, right? That's what the whole opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent is telling us. So 0.7105. This one's going to go 4 decimal places because that's one of our chart numbers. So kind of in geometry, what we did is we just looked on our tangent column till we got close to the angle, right? And it looks like it's, it's between here and here. It's between 35 and 36 degrees. It looks like it's a little closer to 35 degrees. So I'm going to go ahead and call it 35 degrees. Now, here's the symbolic way that we're going to write it. Inverse tangent of 0.7105. So that little -1 indicates inverse trig. It doesn't mean we're going to do 1 over the tangent. It doesn't mean cotangent. It just is a symbolic notation that to say we're doing inverse trig, and that means we're finding an angle. So I said, hey, that was about 35 degrees. All right, and now pretty much I feel like for the rest of this unit, we're not going to really be using that trig ratio chart. We're going to just be using our calculator. All right, so I will show how to use the calculator on this next one. If you don't know how, this is opposite over hypotenuse. So that is a sine. So sine of theta equals 40 over 42. All right. So now we're going to say theta is equal to inverse sine of, all right, I'm going to do it kind of, this is the medium length way, 40 divided by 42 is 0.9524, 0.9524. Okay, and now I'm going to go ahead and punch that straight into my calculator. Okay, instead of using the chart. Okay, so the calculator, all these scientific calculators have inverse trig buttons as well, so we're going to be using those. So I'm going to go inverse sine of 0.9524. Inverse sine of 0.9524. And it's 72.3 degrees. So, on the chart, you can't get a decimal. On here, you can. I'll just take it 1 decimal place. But a lot of times with angles, I just say keep it at the nearest angle. All right, and then the even shortest way to do this is to, let's make that our theta. This is a cosine. Cosine of theta equals adjacent over hypotenuse. So instead of dividing 13 by 20 in my calculator and writing that out, the shortest way possible is to say, hey, inverse cosine of 13 over 20. Okay. So I'm going to say inverse cosine of 13 by 20. All right, so 49.5 degrees. Okay, so moving on now, what I wanted to do is present the dilemma that happens in trig beyond geometry. So let's go ahead and without a calculator figure out what the sine of 30 is. All right, so in order for me to find the sine of 30 degrees, I need to have a triangle so I can use SOHCAHTOA. All right, so I'm going to make my XY grid. Here's my 30-degree angle, and I'm going to drop my perpendicular down to the X always. And then, so then I know that this is a 30, 60, 90, and I have it memorized. Memorized, this is very important. You have to have the basic sides memorized of this family. Across from the 30-degree angle, we're just going to put a 1. That's the shortest side. Hypotenuse is always double, and long leg is whatever the short leg is, 1 times the square root of 3. All right, so sine of 30 degrees is opposite over hypotenuse. Opposite over hypotenuse. Okay, now what happens when we do the sine of 150 degrees? We need to make a triangle. All right, so 150 degrees rotates past the 90 into quadrant 2. Right, and if this is 150 degrees and this is 180 all the way over to here, I know that this has to be 30 degrees. Drop my perpendicular down to make my reference triangle. It's another 30, 60, 90 degree family. And I have memorized across from the 30-degree angle is 1. Hypotenuse is double that. Long leg is root 3. All right, so sine of 150 degrees is equal to opposite over adjacent 1/2. Right? So look, 2 different angles give me the exact same side ratio. That never happened for us in geometry because we only ever dealt with, quadrant 1 triangles and angles and whatnot. But now that we're rotating through the quadrants, we have this double dilemma here. And so we're going to figure out how to deal with that when we do our inverse trig. Okay, here's just another example. It happens with all of the trig ratios. I didn't give an example of cosine, but let's do this one of tangent. I patched this up because I was going to I'm planning to change your notes. I just didn't want to reprint mine. Okay, so we're going to rotate a 45-degree angle, right? Drop it down. And on this family, 45, 45, 90. And again, without trig, we're always in one of our 2 known families. So make the legs 1 and 1, which means the hypotenuse is whatever the leg is times the square root of 2. All right, so the tangent of 45 degrees is opposite over adjacent, which is 1. So what happens if you do 225 degrees, right? So that's going to rotate past 90, past 180. It goes down into quadrant 3, and if you wanted to figure out how far past, you just take 225 and you subtract away the 180 degrees, and you get 45 degrees right here. Okay, so that's a 45 degree. We're going to make our to the x, leg, negative in the x direction, negative in the y direction, so -1, hypotenuse always positive. So the tangent of 225 degrees is equal to -1 over -1, right? Which is, I'm almost off my screen, which is another +1. So we have the same dilemma, and that is that the quadrants, this is quadrant 1, right? Quadrant 1 and quadrant 3 for the tangent are going to produce the exact same side ratio. For the sine, this is quadrant 1 and this is quadrant 2, right? For the sine, quadrant 1 triangles or angles and quadrant 2 angles are going to produce the same ratio. So our dilemma is when we get into inverse trig. So that's like, hey, say what theta is going to produce a side ratio of 1/2, right? And that's what we're going to be trying to figure out. We're going to practice it a lot more on the back side, but I've already just got it right here. And the problem is that a 30-degree angle gives us 1/2, and a 150-degree angle also gives us 1/2. So how do I know which answer to give? Or should I always just have to give them both? And the answer is we're only going to give one answer, which is the right one, the 30 degrees and the 150. So now we have to introduce, and I copied them out of the book and put them on here, and I wanted them to fit on the front page, so they're kind of micro-sized, but we have these restrictions on our inverse trig functions. And so we're going to follow these, and that's going to tell us which angle I am going to give. All right, so let's just look at the inverse sine. So what this means is that the shading represents the two quadrants where I am going to actually give answers in, which means for me, for the inverse sine, I mean, no answers are going to be given in quadrants 2 and 3. So when I look back up here and I'm like, how do I know what answer I'm going to give? Because there's two triangles that will produce, or two angles that produce that same answer. I'm going to go look at my restrictions and to say, hey, for the sine, I'm not going to give any answers in quadrant 2. So this would not exist, right? That 150 would not exist. All right, and so I'm only going to say it's 30 degrees. And these ranges are what our calculator gives. Like if we're going to plug this into our calculator, this is the range that our calculator would give. So how would it look when I plug it into my calculator? So remember, when I'm finding a theta, that means I'm doing inverse trig, inverse sine of 1/2. Okay, so if I just plug it in, inverse sine, whoops, right, I did second function sine of 1/2, that's like a 0.5. So that gives me that 30-degree angle. It doesn't give me the 150. Now, we're going to have to be able to do this without a calculator at times, right, whenever we're doing our actual triangle families that we know. So we have to learn how to do it without a calculator. And again, we didn't have to worry about this in geometry, because in geometry we only ever dealt with quadrant 1 angles. Wow, my exposure just is going a little crazy here. Turn it down. There, maybe that's a little better. Sorry. And okay, so and then the cosine has this restriction on it. We're gonna have to revisit these. I'm gonna have to flip-flop my paper back and forth. And then the tangent has this one. Okay, so remember, the tangent produces the same answers in quadrants 1 and 4. Oh, and, 1 and 3. And it does the same answers in 2 and 4 if you end up, having negatives. So we're going to only restrict our tangent answers to quadrants 1 and 4. So tangent and sine, they have the same restrictions, and cosine goes here. So this is shown in radians and in degrees. So notice that it's not, the range is negative 90 to positive 90, which means when we give answers, we're supposed to give answers in this range, which is going to be different for us because it seems weird to give a negative angle measure, but that's what we're going to be doing. Inverse cosines, at least, are always positive. They're between 0 and pi, or between 0 and 180, depending on if we're in radians or degrees. And inverse tangents, again, here's our degree range, and here's our radian range. Okay, so let's go ahead and try some of those examples on the back. Okay, on second thought, I think I'm going to end this video here and make a second video of the backside.